Hey folks, in this video we're going to talk about your television set. And Primarily we're going to talk about the cost of electrical something and also talk about how to generate electricity, in the basic sense. So first of all, when you pay your electric company, what are you paying for? Okay, well, you're not paying for charge because the wires are full of charge already. The net charge is zero. Matter of fact, your household circuits are alternating current, which is short AC, which means the electrons go back and forth in the wire 60 times per second, which means the net number of electrons that enter your house in a given year is zero. So you're not paying for charge. Are you paying for current? Well, no, because you're not paying for charge and current's paid the charge. You're not paying for voltage because voltage is always 120 at our house. If you're in Europe, it's 220. So what are we paying for? Well, you're paying for what you pay anybody for. You're paying for work. All right. Now, let's say that you have a 400-watt television set. All right. And let's say you have it on for 1 hour. So just your television set for just 1 hour. The power company will charge you for the work done to keep that TV on. So the bigger the wattage of the TV, the more it's going to cost, and the longer you have it on, the more it's going to cost. Okay. Now, normally when we do work, when we talk about work, okay, that would be power times time, right? So in this case, the power is 400, and these are watts, and then the time would be 1 hour, which is 3,600, and that would be seconds. So a watt times a second would give you, in this case, 1,440,000 joules, or 1.44 megajoules. A mega is a million. Okay. Now, that's a joule is a relatively small unit of energy. So think about what your electrical bill would say for a month. If you had everything on there, it'd be in the billions of joules. Okay, and so the power company's not going to list it that way. So what they're going to do is they are going to take same thing. It's still power times time, but the units they're going to use are kilowatts, and the time they're going to use are no, I'm sorry, not seconds, but hours. Okay, so they're going to take kilowatts times hours. So for this example, 400 watts is zero point 0.4 kilowatts, and the time I'm giving you is exactly 1 hour. So the amount of energy we've got is 0.4, and the units are kilowatt hours. So if you look at an electric bill, you're going to see kilowatt hours. And again, it's not per hour, it's kilowatts times hour, and that is energy. Okay, it's just a different version of energy. It's just like instead of measuring in inches, we're measuring in miles. Same idea. Instead of measuring in joules, we're measuring in kilowatt hours. Now, just for kicks here, I do have a electric bill from a couple years back. I'm not even sure it's mine. It might be one of my colleagues, but so you'll notice here there's a bunch of things listed. This is the energy that this person used in that given month. So just over 1,000 kilowatt hours. And you'll notice the biggest charge, or the biggest dollar sign, is the first one that says, where is it at? The biggest one is the energy supply charge. So see the $75 here? So that's energy. That's the work they're doing for you. And that's about 7 cents per kilowatt hour. Now you'll notice there's also about a 2-cent charge per kilowatt hour to keep up the facilities and such. If you add all this up in this particular example, it's about 10 cents per kilowatt hour. So that's the cost that we're being charged for the work that that the power company does for you. Okay, so assuming that the cost of energy is 10 cents per kilowatt hour, okay, how much would it cost to run this TV for 1 hour? Okay, well, this is really simple. Cost is equal to 10 cents per kilowatt hour times our 0.4 kilowatt hours. Okay, the kilowatt hours will drop out and you'll get 4 cents. So that television set cost 4 cents to power for 1 hour. So pretty cheap, right? Okay, but how much coal would that take? So let's say you were using coal, a coal-fired power plant, to power that TV for that 1 hour. Okay, so if you look up coal, coal has an approximate energy value, and I'll write this down, of 33 megajoules per kilogram. So if you have like a book's worth of coal, that's about 2 or 3 kilograms, so it's about 70 megajoules of energy. Okay. Now, a typical coal-fired power plant is only 25% efficient. In other words, of these 33 megajoules, only a quarter of them actually go to make electrical energy. The other 3/4 are generally wasted as heat. So for powering ourselves, we're going to get about a 25% efficiency off this. So if you take 25% of 33, you get 8.25 megajoules per kilogram. That's actually going to go to powering our TV set. So how much coal is that? Okay. Well, that would be the energy density. Okay, so density is equal to energy divided by mass. So mass that we're going to use would equal energy divided by density, right? This rho. So the amount of energy we needed was 1.44 megajoules for our TV set for that 1 hour. And then the density is 8.25 megajoules per kilogram. If you take megajoules divided by megajoules per kilogram, you end up with kilograms. So if you work this out, you get about 0.175 kilograms, which is about 175 grams. Okay, so that's about the mass of your calculator, give or take. So basically, you'd have to burn 1 calculator every hour, okay, just to keep your one single individual TV set running for that 1 hour. Okay. Now, I want you to imagine how much that is for, let's say, 100 million people watch their TV set for 1 hour in one day. That's a very conservative estimate in the United States. All right. Well, then you're talking how many kilograms? Okay. Well, if you take this times 100 million, you get 17 million, and then I'll round it to 500,000 kilograms, or 17.5 or 17,500 metric tons of coal every day just to power our television sets for 1 hour. Okay, imagine everything else that we're running in a given day. Now, think about how much coal this is that we're taking out of the ground to power these things. And we're not even the biggest country, right? There's other countries that are bigger than us that are using even more energy. Okay, so the reason I bring this up is we need to think really hard about where we get our energy from and how we're using it. And basically, all this energy, by the way, all this coal is becoming garbage, and even all that energy, even the energy that powers the TV, eventually becomes heat. So eventually it's all wasted. So hopefully some of you out there will think about other ways to generate electrical energy that are more efficient and more clean than this. So I hope that video was helpful, and thank you very much.